In this video, we're going to take a look at properties of parallelograms again. We're going to add a property to the 4 that we've already covered, and we're going to talk about the properties of a rectangle and a rhombus. So let's focus in on the properties of a parallelogram. We have already talked about how opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and today we're going to add a property to our list and say diagonals bisect each other in parallelograms. And let's draw a picture of what that looks like over here to the side. So if we draw a little parallelogram over here, and we draw the diagonals of the parallelogram. So a diagonal goes from, sorry about that, goes from one corner to the one on the opposite side. So we draw the diagonals, and it would bisect each diagonal, so they have 2 equal parts on either side of where they intersect. When something is bisected, it's broken in half. So that would be what happens with this 5th property of parallelograms. Now for rectangles, a rectangle is a parallelogram, so it has all 5 properties of a parallelogram. So all 5 of the ones we've just named off would apply to any time you have a rectangle in a problem. There are also 4 angles in a rectangle that are all right angles, and the diagonals are congruent to one another. So in a rectangle, each angle in that rectangle is a 90-degree angle. And then the diagonals are congruent to one another. So if we have a rectangle called A, B, C, D, AC is congruent to BD. All right, and let's take a look at rhombus. So a rhombus is a parallelogram as well. So all 5 properties of a parallelogram would apply, and they're written up above there. And then you also have all 4 sides congruent in a rhombus, and diagonals are perpendicular, and diagonals bisect opposite angles. So let's draw those out here to the side for a minute. So I'm just going to try to sketch a little rhombus. It kind of looks like a parallelogram, but try to make it so all 4 sides look like they're equal length. So all 4 sides are congruent. We just put a little tick mark. Diagonals of a diagonals of a rhombus are perpendicular to one another. So that means they form 90-degree angles where they intersect in the middle. So all 4 of those angles are 90-degree angles. And then the last property that makes a rhombus special is that the diagonals bisect the angles that are at the vertex. And they're opposite of one another. So all 4 of those little angles would be equal to one another, as well as these 2 are equal to each other, and they're also equal to the 2 that are opposite of them. Okay, so we're going to take a look at a mixture of examples on parallelograms, rectangles, and rhombuses to apply these properties and solve some problems. So number 1, it says, given the parallelogram below, TE equals 4 plus 2x. And EV equals 4x minus 4. So since they've told us that this is a parallelogram, we know that the diagonals bisect each other, which means it breaks them into 2 equal parts. And so we can say that 4x minus 4 would equal 4 plus 2x. We're going to solve for x, but then we need to remember to come back and find the length of TE to answer the question. All right, so I'm just going to solve for x for a minute. So let's subtract 2x from both sides. And we have 2x minus 4 equals 4 left over. We can add 4 to both sides, so we get 2x is equal to 8. And divide by 2, so you get x equals 4. But you just want to plug it back in to find the length of TE. Now we know that TE is equal to EV, so it doesn't really matter which one you plug it back into to figure that out. But I am going to plug it back into the TE that they mentioned, just to keep it simple. So 4 plus 2 times x, which we found was equal to 4, would equal TE. So 4 plus 8 would just give us 12. So on any geometry problem, be careful that if you solve for x, is that what they were asking you for? Or do you need to plug it back in to find the length of something or an angle measure? So always keep that in mind. All right, number 2. Given the parallelogram below, UH is equal to 19 and FH. So notice FH is this whole diagonal. And they told us that's 5x minus 7. And we need to solve for x. So we know in a parallelogram that the diagonals are bisected. So we know that this segment is 19, but then this one over here will also be 19. And then they've told us that the total length is equal to 5x minus 7. So in order to find x, we need to say 19 times 2, or 38, would equal the total, which is 5x minus 7, and then we can solve for x. So I'm going to add 7 to both sides and get 45 is equal to 5x, and then just divide both sides by 5. And we get 9 equals x. And then that is all they were asking for, so I don't need to plug that back in anywhere. All right, let's look on the next page. Number 3 says find the values of x and y that make LMNP a parallelogram. So the property that they have focused on in this problem is, again, that the diagonals of a parallelogram bisect one another. So we can set up that these parts are equal and solve for x and y. So we can say 2y minus 7 is equal to y plus 2. And we can say 3x is equal to x plus 5. So then we can solve and see what we get for x and y. So I'm just going to subtract y from both sides, and I get y minus 7 is equal to 2. I'm going to add 7, so I just get y is equal to 9. And I get 2x equals 5. So divide by 2, and I get x is equal to 5 halves or 2.5. Okay, and then double check you don't have to plug it back in, and we don't because they just said find x and y. So we're good with number 3. Number 4 says find the length of the diagonals of rectangle GFED. If FD, so they said FD is equal to 2y plus 4, and GE, so GE is the other diagonal, and that's equal to 6y minus 5. So in a rectangle, because that's what they said this figure is, they need to state that for you to know that, because you can't assume that it's a rectangle without some more information. But we know it's a rectangle because they said that it was. And so we know the diagonals of a rectangle are equal in length. They are congruent. So we can say 2y plus 4 is equal to 6y minus 5. And they have said to find the length of the diagonals. So we need to solve for y and then plug our value back in to figure that out. All right, so let's subtract 2y from both sides. We get 4 equals 4y minus 5. So we get 9 equals 4y. We could divide by 4, so y is equal to 9 over 4. But now we just want to plug that back in and be able to find the length of each diagonal, but they're equal to one another, so you can plug it into either one of the values they gave you. So I think that 2y plus 4 looks a little easier to plug it into. So I'm going to say 2 times 9 over 4 plus 4 is equal to FD. and FD is equal to GE. So no matter which one I plug it into, I should get the same thing. So I get 2 times 9 is 18 over 4 plus 4. And I'll just bring that other part down. FD and GE are equal to one another. And I'm going to put the segment symbol above those. And then 4 has a denominator of 1. So I'm just going to get a common denominator of 4. So I would say 18 over 4 plus 16 over 4 would equal my diagonal length. I'm just going to bring that down. So 18 plus 16 would be 34 over 4, or 17 over 2, or we could say that is 8.5 is our length of our diagonal. So you could certainly use your calculator to help with that. I was just working it out by hand. All right, let's take a look at number 5. 5 says find the length of the diagonals of rectangle GFED if FD, so that's that whole diagonal, is 5y minus 9. And they said GE, so again, that's the whole diagonal, is y plus 5. So it's a very similar problem to the one we just worked out. So let's start by setting them equal to one another, because we know that they've said it's a rectangle, so the diagonals are equal to one another. We're going to solve for y, so let's subtract y from both sides. So we get 4y minus 9 equals 5. Let's add 9, so we get 4y equals 14. And divide both sides by 4. So we end up with 7 over 2, or 3.5 for our value of y. But then they want to know the length of the diagonals, so we want to plug that back in. And I would say that this one right here looks easier because it's just y plus 5. So if I have y plus 5 and I need to plug in y equals 3.5, that's pretty simple to plug that back in. So I just get 8.5 for the length of the diagonals. Let's look at number 6. So 6 says MNPQ is a rhombus and measure of angle N is 120 degrees. Find the measures of the numbered angles. So in a rhombus, one of the properties of a rhombus is that it's it has all the properties of a parallelogram, first of all. So we would know that if this angle is 120 degrees, the angle opposite of that is also 120 degrees, because that is the property of any parallelogram. And then we also know that these angles that are consecutive, so for instance, the 120 degrees plus this angle P right here, like 3 plus 4, that whole angle in the corner, those have to add up to equal 180 degrees total. And so we would know that angle P total would have to be 60 degrees because this angle N is 120 degrees. And then because it's a rhombus, which they've stated in the problem, we know that these diagonals in a rhombus bisect the angles that are at the vertex that they intersect with. And so angle 3 and angle 4 would have to both be 30 degrees to add up to be that 60 degrees that we know P is equal to. And then we know if angle 3 and 4 are 30 degrees, the ones opposite of that are also 30 degrees. So we found all of the measures of the numbered angles for example 6. Let's see. Number 7 says find the measures of the numbered angles in the rhombus. So let's start with what they gave us. We have a 50-degree angle that goes with this one. So we know the one beside it is 50 degrees and the ones opposite are also 50 degrees. We know based on a rhombus that the diagonals are perpendicular to one another, which makes angle 1 equal to 90 degrees right there in the middle. And if that one is 90, then this one right here is 90 degrees. So we could figure out angle 4 a couple of different ways. I am going to look at it as a parallelogram. So like this corner here is 100 degrees total. So where angle 4 is sitting is in this corner. Well, these two are consecutive angles, so we know they are supplementary with one another. So we know that this corner where angle 4 is sitting, total would be 80 degrees, which means that there's 40 degrees for each one of those. So angle 4 has to be 40 degrees. Notice one more thing in that figure. So you see how you have a triangle right here? And we know that triangles always should add up to 180 degrees. And notice 40 plus 50 plus 90 does in fact add up to 180 degrees for that triangle. Okay, so I think this is our last example, number 8. Find the values of the variables for the rhombus and then find the lengths of the sides. So we know for a rhombus that all 4 sides are equal to one another, but this side has B and this side has A, for example, so we can't just set them all equal to one another. We're going to need to say 3B plus 2 equals 4B minus 2 because they both have the letter B. And that way we're going to be able to solve for B. So let's say 3B plus 2 equals 4B minus 2 and solve for B. So I'm going to subtract 3B and I get 2 equals B minus 2. And then I need to add 2 to both sides, so I get B equals 4. Now, I'm going to uncircle that because that's not the answer to the question. The question said, find the lengths of the sides. So let's work on that in just a minute. Let's say 5A plus 4 equals 3A plus 8. And let's solve for A. And then we'll plug A and B back in to figure out the lengths of the sides. Okay, so first I'm going to subtract 3A. So I get 2A plus 4 equals 8. I'm going to subtract 4, so I get 2A equals 4, and I'm going to divide by 2. So I get A equals 2 for the value of A, and B was equal to 4. Now let's just go back and plug those into the sides. And so 3 times B, which was 4, plus 2. So that would give us 12 plus 2, which is 14. And let's just make sure it matches what's on the other side. So we have 4 times B, which is 4, minus 2. And that's 16 minus 2, which is indeed 14. And they should all equal 14. But just to check your work, you might want to keep plugging them in and make sure they make sense. So let's just continue for a minute. 3 times A, which is 2, plus 8. So 3 times 2 is 6. 6 plus 8 is 14, so that one looks good. And then our last one is 5 times 2 plus 4. So notice they do all make good sense, and they are all equal to one another, which they should be because we were told it was a rhombus. Okay, so that's it for the notes for today. Thank you for listening.